Good morning, students. Let's continue with the second part of the quadratic equation with most likely questions. So first question that will solve the quadratic equation. Solve quadratic equation, and the equation is 16x minus 10 upon x is equal to 27. We'll solve this equation by both the methods. First, that is the factorization, middle term separation, and second one, formula method. By both the method, we'll solve the same question and we'll check also that whether we get the same zeros or not. So first we have to simplify this because this is not in a quadratic form. So multiply both sides by x. So it becomes 16x, 10, x will get cancelled, and this is 27x. We'll rearrange this. This becomes 16x square. This plus on this side minus 27x minus 10 equal to 0. So first method is middle term separation. So we want the addition as 27, and we have to multiply coefficient of x square with the constant term, that is 16 into minus 10. So 16 we can write 8 2s, and this 10 can be written as 5 2s. The whole product becomes minus. But we are looking for the addition minus 27. So 8 5s are 40. So it cannot be. So 8 2 2s are 4. 8 4s are 32. And this 5. We are looking for minus 27. So minus 32 and plus sign with 5. So minus 32 and plus 5 are the factors. So we will write it down in the middle term separation form. Minus 32x plus 5x minus 10 equal to 0. Say this. Minus 32 plus 5 becomes minus 27, and their product is this one. Now we'll take the common. Here we can take 16x common, so x minus 2. Here we can take 5 common, so x minus 2. So we got the zeros as x minus 2 into one bracket, and this 16x plus 5 into another bracket. So if we equate with 0, we'll get x equals to 2, and second x equals to minus 5 by 16. So these are the zeros. So let's consider this alpha as 2 and beta as minus 5 upon 16. So this method is called middle term method, that is factorization. We'll discuss the same question by using the formula method. So let's solve the same question by using the formula method. Just remember the zeros are 2 and minus 5 upon 16. Again, for the formula method, again we have to write down this equation into the standard form. So for standard form, again we have to multiply by x's, then this 27x, and the form of the equation 16x square minus 27x minus 10 equal to 0. Now we'll discuss the formula method. So we have to compare it with the standard, means form of the quadratic equation. So here we got the values a as 16, b as minus 27, and the constant term c as minus 10. So first we'll write down the formula. Formula is minus b plus minus root b square minus 4ac upon twice of a. So whenever we solve the quadratic equation by formula method, first we're going to find the formula, the discriminant value. The discriminant value will decide nature of roots. If the roots are not real, we'll stop here. And if the roots are real, distinct or equal, we'll solve them further. So b, what is the value of b? b is minus 27. What about the 4? Into a is 16. and C, the constant term, is minus 10. So we have to find the square. Now square of the 27, the square of two-digit number, by using the a plus b bracket square formula you can find easily. 7 square is 49, carry 4, 7 2s are 14, 14 2s are 28, 28 plus 4 32, will carry 3, 2 square 4, 4 plus 3 7. So like this way we can make use of a plus b bracket square formula to find square of two-digit number. Now this minus into minus plus, 16 4s are 64, that is 640. And then we add this 2, 9, 6 plus 2, 4 plus 2, 6. And then 9, 6 plus 7 plus 6, that is 13. 1, 3, 6, 9. This is b square minus 4ac, which is a positive value, means roots are real and distinct. Distinct means different. So we'll make use of this value to find the roots by putting the value into the formula. I have to rub this part. Again, we'll write down the formula. X is equals to minus b plus minus. Whenever we took the square root of constant number, it should be plus minus b square minus 4ac upon twice of a. We'll write down here b. So value of b is minus 27 plus minus root. The value of b square minus 4ac is 1369 upon 2. The value of a is 16. So again the value of a is 16. Again the student face problem for finding the square root of this 1369. They are not able to find the square root of 1369. Again we can find it by the method that learned in the 8th standard. So see that method, we make the pair of two groups of the number digits. This 13, so we can deduct the square of the 2. 2 square is 4, 3 square is 9, 4 square is 16. So 3 square that can be subtracted. So we have to write down that 3 times. Here the square of the number and subtract. Here is 4. Take this group as it is down. Add these two numbers. Here is 9. So we'll take 3 is 9, 6 3 is 18. Again we'll check which number having the ending with 9. So here 6. 3 3 is 9. One more point we can take 3. After that 4 4 is 16, 5 5 is 25, 6 6 is 36, 7 7 is so 7 7 is 49, 7 6 is 42, 42 plus 4, that is 46. So we got that number. We have to write it down 3 times. So 469. If we subtract, we got 0, and the square root of this number is 37. So we'll make use of this number to find the zeros, that is roots of the equation. So x is equals to 27 plus minus 37 upon this 32. So first root we can say it is alpha, so we'll take the plus sign and we'll divide it. The second root we'll take as a beta, and 37 subtraction this 32. So if we add this, 7 plus 7 14, 3 plus 3 6, so 32 2s are 64. So first root is alpha. Do you remember what answer we got in the factorization method? The same one. This is 0, 3 minus 2 1, this minus sign upon 32. If we divide it by 2, 2 5s are and 2 16s are. These are the zeros of the quadratic polynomial by factorization method. So in factorization method, there are two important terms. First, we need to find b square minus 4ac value always separately. Then there is a problem to find the root of the term. At that time, we can make use of the method of the division method by its standard. Then we'll find the zeros. This is the only method which is useful to find the roots of all types of equation. There are limitations for middle term separation method, but if the roots are real, then we can find by using formula method. Let's discuss one more question related to the quadratic equation. So second question is root 2x square plus 7x plus 5 root 2. This is a quadratic polynomial. Now let me read the question. Determine given quadratic equation have real roots. First we have to determine whether this equation having real roots, and then we have to find also. So let's discuss the solution. Ax square plus bx plus c. First part to compare with the standard form. So what is the value of a? Root 2, value of b 7, and value of c, that is constant 5 root 2. Now the discriminant value. Okay, so discriminant value delta is equals to b square minus 4ac. Okay, so we'll write down here discriminant value, we'll put up the value b. What is the value of b? B is 7 minus 4, value of a is root 2, and value of c is 5 root 2. If we multiply, 7 square is 49, root 2 into root 2, 2, 5 4s are 20, 22s are 40, that is 9. So the delta, that is b square minus 4ac, is greater than 0, that is the positive value. And as the value is positive, roots are real. Roots are real. Now we'll suggest you, whenever the root term is there, we prefer the formula method to find the roots. It is simpler for understanding, and we already got the value of b square minus 4ac, so we can easily find the further roots. So we'll write down the formula. X is equals to minus b plus minus root b square minus 4ac upon twice of a. So what is the value of b? Here b is 7 plus minus root b square minus 4ac, already we got as a 9. 2, value of a is root 2. Now minus 7 plus minus 9 square root is 3. This is 2 root 2. Now you can see, if we took the plus sign, then we'll get first root. If we take the minus sign, we'll get the second root. So I'm going to solve this here just because of the space. Alpha, so first root minus 7 plus 3 upon 2 root 2. So minus 7 plus 3, that is minus 4 upon 2 root 2. 2 ones are 2 twos are, and this further root 2 root 2, that is root 2. Further we can divide it to root 2 into root 2. 1 root 2 will get cancelled. What about the second root? We have to subtract this. So minus 7 minus 3 upon 2 root 2. Again this becomes minus 10 upon 2 root 2. Then 2 ones are and 5s are, that is minus 5 upon root 2. So these are the zeros. This is a beta and this one is a alpha. We'll take one more question. Word problem. We'll go for now the word problem which are most likely related to the chapter quadratic equation. So I'm going to read the question. The question is, sum of the two numbers a and b is 15. Sum of the two numbers is 15. It is a and b, so a plus b equals to 15. Sum of the two numbers is 15, and sum of their reciprocals 1 upon a and 1 upon b is 3 upon 10. Sum of the two numbers is 15. The numbers are given a and b, and the sum of their reciprocals, that is 1 upon a plus 1 upon b, is 3 by 10. Find the numbers. So we can find it by solving. So a plus b equals to 15, and here 1 upon a, 1 upon b are given. So we'll simplify this. A plus b equals to 15. We can replace b by a. So 15 minus a. So this is our need. Put this value between equation 2. So we'll put this value in the second equation. So 1 upon a plus 1 upon b equals to 3 upon 10. 1 upon a plus 1 upon in place of b. Put 15 minus a, and is equals to 3 upon 10. Now we'll simplify this. If we cross multiply, it becomes 15 minus a, this plus a, in denominator product of these two terms, and is equals to 3 upon 10. Again plus a minus a cancel, will multiply, so 3a, 15 minus a. Now this is 150, this is 15 3s are 45a minus 3a square. We'll prepare it into the standard form. So transfer it, 3a square minus 45a plus 150. We can divide it by 3. If we divide it by 3, then it becomes a square minus 3 1s are 3, 3 5s are 15, 3 5s are 15 equals to 0. Now we can find factors directly. Why? Because here the coefficient of a square is 1, so we can find the factors. So 5 into 10, 5 into 10, 50, and this minus 5 minus 10. So minus 5 minus 10 becomes minus 15. So roots are a minus 5 and a minus 10. So a equals to 5 or a equals to 10. Now we got the two solutions. So what about them? The both are the correct one. So a equals to 5. If we put a equals to 5, we'll get the value of b. So if we put a equals to 5, the b becomes 15 minus 5, that is b becomes 10. And if we put a equals to 10, then we'll get 15 minus 10, that is b equals to 5. So when we'll take the a as 5, the second, the two numbers a and b. If a is 5, b 10, and if a is 10, b is 5. Both are answer. So you can write down that as a or. A 5, b 10, or a 10, b 5. Like this we can write down the answer. Let's solve one more important question related to the quadratic equation, which mostly asks in the exam, and it is also a word problem. So let's see. A two-digit number. Question is, a two-digit number is such that the product of its digit is 24. Product of the digit is 24. If 8 is subtracted from the number, the digits interchange their places, find the number. So let's discuss this. First of all, two-digit number. So two-digit number we'll discuss in detail. What is two-digit number? In two-digit number there are two places. One is unit place and second is tens place. And we form two-digit number. So unit place to be multiplied by 1 and tens place to be multiplied by 10. So here if we consider unit place and tens place as x and y, then two-digit number 10 into x becomes 10x plus y. This is a original number. This one is a original number. And if we interchange means unit place, y is in 10 place and this one is here, then the number form is 10y plus x. This is a number when we interchange the digits. So this is the simplest form we can prepare. So according to the condition, now we'll solve this question. Now product of the digits is 24. So x into y is equals to 24. So we can replace y by x. So what is the value of y? Y is 24 upon x. Now we'll make use of the second condition. If minus 8 means 8 is subtracted from the number, that is 10x plus y, and 8 is subtracted, then he said that the numbers, the digit interchange their places. Then digits interchange their places means 10y plus x, the new interchange digit number will appear, means it is equal. So we'll solve this too. Now 10x, this x we transfer, so 10x minus x plus y minus 10y, and this minus 8 on the right hand side, so 8. Now we find that 10x minus x is 9x minus 9y is equal to this minus 8 on this side plus 8. Now we'll make use of the value of the y. What is y? Y is 24 by x. So 9x minus 9, the value of y is 24 upon x is equal to 8. Now we'll simplify this, we'll get 9 x square, we can take common 9 as a common, so it will be easier. So x square minus this 24 and here 8x. So we can form a quadratic equation. Quadratic equation becomes 9x square, this minus 8x, this we can multiply, 9 4s are 36, 9 2s are 18, 18 plus 3, 21 equals to 0. Now we can find the roots of this quadratic equation. As we'll find the roots of the quadratic equation either by middle term separation. Either you find by middle term separation or by formula method. So we'll get the answer as the value of x and y will get, and the number will be 64. We'll get the 2-digit number as a 64. So you can solve this quadratic equation by middle term separation. Why I am suggesting middle term separation? Because these terms are larger, so b square minus 4ac will have some more square root and terms will be larger. So I refer middle term separation to solve the factors, and the number is 64. So 2-digit number will be 64. Let's discuss one more important question related to the quadratic equation, and the question is find k if the roots are real and equal. This is mostly asked in the exam. Find k if roots of the quadratic equation are real and equal. The roots are real also and equal also. So we must remember the condition for real and equal roots. So x plus k square equal to 0. So here roots are real and equal. First we'll compare it with the standard form. Ax square plus bx plus c equal to 0. So can you guess the values of a and b? The value of a is 1, b is minus 2 in bracket, k plus 1. If you forgot to take minus sign, answer differ from the real one. Now the roots are real and equal. Real and equal. So b square minus 4ac equal to 0. This is the condition. Now put the value b square, that is minus 2 in bracket, k plus 1, this whole bracket square, minus 4 into value of a is 1, value of c is k square is equal to 0. Now we'll simplify this equation. So minus square becomes plus, this becomes k plus 1 bracket square minus 4k square equal to 0. We have to use here a plus b bracket square formula. We'll use that, k square plus 2k plus 1 minus 4k square equal to 0. If we multiply, we'll get 4k square plus 8k plus 4 minus 4k square equals to 0. In this question, 4k square, this step, minus plus will cancel, so 8k plus 4 equal to 0, 8k equals to 4, this is minus 4, so minus 4 upon 8, so k equals to minus 1 by 2. So we'll get the answer by solving this type of question. The method to solve, we must remember the condition for real and equal, real and distinct, and roots are not real. If the roots are not real, we cannot solve it by any of the methods. So in this way, you can study the chapter quadratic equation and few most likely questions that we discuss. More questions like this are the